Okay, little one. We got everything else done. I have all those bolts chased, and now what I'm going to do is get the pistons ready to put on the motorcycle, right? So, in general, your engine's just a big thing to pump air around and take advantage of some physics. Basically, the piston starts at the top, the exhaust valve or the intake valve opens, and when the piston comes down, it creates a vacuum and it sucks air in through your carburetor. The carburetor mixes gas with air, and it fills up the whole cylinder with gas air, or it's known as fuel air mixture, right? As it continues, the intake valve closes and the piston comes up and compresses this mixture of fuel and air into the combustion chamber here. At the exact right time, the spark plug fires and it burns the fuel air mixture, creating a whole bunch of heat, which is, as we know from physics, energy, right? That will then push the piston down. That's called the power stroke. The first one down is intake, compression, power stroke, right? At the end of that stroke, the exhaust valve is going to open, and because you have a flywheel and inertia and shit, the piston's going to continue. It's going to come up and it's going to push the exhaust gases out. All right, pretty simple. So the piston in general is fitted to the diameter of the cylinder here, right? Now, it's important when you buy a set of cylinders and pistons that, you notice I marked that R and that R. It just means rear to me, because they've bored and honed this steel liner inside the cylinder to an exact dimension to fit this particular piston. Now, they make these pistons by the gazillions, and there's always a little bit of difference in size, all right? So you don't want to mix up your pistons and cylinders, right? So what we have is we have two dissimilar metals, right? The steel of the liner and aluminum of the piston, all right? So you remember your physics, right? Different metals expand at different rates depending, for temperature. So there has to be a way to seal the cylinder and piston together, right? And as the piston grows at a different length and the cylinder expands at a different length, you still got to maintain that seal. And the way they do that is with these things called piston rings. Now I have a set of piston rings that came with the kit I brought, right? And you'll see on the side of the piston these grooves. They're called lands, all right? And the rings are going to fit in these grooves here. It's going to be hard for me to show you doing it. I'll show you the end result. But what you have to know is there's different rings for different purposes, okay? And on this little sheet here, it shows me that piston ring goes there, that piston ring goes there, and that piston ring goes there. Couldn't be simpler. So that piston ring is what's known as the oil scraper. All it does is scrape the oil that gets by the other two rings. These two rings are called the compression rings, all right? They actually make the seal with the cylinder wall in order to create the pressure we want, all right? So what I'm going to do is I'm going to put these rings on here. Basically, you kind of oil them up a little bit and get them on there, and we'll talk about that in a few moments. All right, there's your three sets of rings, all right? This is your oil scraper ring. It's like a three set. You have the scraper, then you have the two keeper rings, all right? And you have your number 2 compression, your number 1 compression. All I'm going to do is take some standard engine oil, and then I'm going to kind of lube up the rings and lube up the piston and mount them, and I'll show you that when I'm done. Okie doke. Okay, so modern manufacturing pretty much makes this step unnecessary, all right? As I told you that piston ring creates a seal, right, between the piston and the wall. Well, it's just you see it's a clip here, right? This thing here, it's got an end to it. So when you put it into the cylinder, there's going to be a little gap there. There has to be, right? In the old days, you take like my shovel head there, a piston ring end gap was like an inch, right? I'm kidding, but to be honest with you, one of the big things with the evolution motor when it came out after the shovel head was that the worn out value for the piston ring gap for the new evolution motor was smaller than the minimum gap for a shovel head. They were real sloppy build. Anyway, I do this on every engine, but I haven't found a bad piston ring end gap in probably 15 years, all right? So what you do is you lube up the ring and you lube up the cylinder there, and put the ring in there. Then I take the piston, I turn it upside down, and I just make sure the ring is in there parallel, right? Perpendicular, whatever word you want to use. And then I look up online what the ring end gap is supposed to be. I have the right feeler gauge, and then I just, I can't see with this, but just slide it in that gap and measure it, and it's good. So I can go on from here. So that's called piston ring end gap check, all right? Okie dokie, I have the rings on the piston. Now, the bottom ring is the oil scraper, and you put the oil scraper in, and then you have an upper and lower ring on top of it. You don't really worry about the gaps or anything where they end up, it doesn't matter. But as we were saying before, when I show you the piston end ring end gap, that leaks a little bit, okay? So the compression rings, you don't want to put where the gap's going to be in the same place. So just as a precaution, I always put one at one side of the wrist pin and one at the other side of the wrist pin, roughly. Now, the big thing you want to do is when you get these together, just make sure everything moves free. Everything should just be kind of sloppy-loppy in there, and that's the way you want it, all right? So, this little thing here is called a circlip, and this is called the wrist pin. And this is the piece of metal that holds the piston to the connecting rod. It's going to slide through that hole there and through the hole right there on the connecting rod, all right? So what holds these into place is this little circlip, all right? It's a real simple system, it works good, but these clips do come out if you put them in wrong, so you want to spend a little bit extra time to make sure you got it in right. So I have one side in, and all I have to do is I'll slide this through the other side, through the rod, and then finish it off with that wrist pin, okay? So that's basically it. I'm going to do the other piston, and I'll get back to you. Now, some people, there's different ways to do this, and you end up doing it the way that works for you, all right? Some people will use a spring compressor and load this into the cylinder and then drop the whole cylinder down and hook it up to the connecting rod. For me personally, I found I have better luck. I will mount this on the connecting rod, then lower the cylinder down on it and compress a ring one at a time. Some purists will say that, oh, that's a bad way, but I've never had a problem with it. So, and I've tried doing it this way, but I end up dropping the whole friggin' cylinder piston assembly that comes slinging down, and it just doesn't work for me. Anyway, see you in a bit. Okay, Keaton. I got all the rings on the pistons. Everything ready to go. One of the things I could tell you is when you're assembling an engine, you really just need to use as much lubrication as you can on as much as possible. My working theory is if it's not hard to hold on to, it doesn't have enough lube on it. So there's two ways of doing it. One is to take that piston there with the rings on it, use a piston ring compressor, press it into the cylinder, then mount the cylinder, connect the piston to the connecting rod. The other way that I do it a lot and freaks people out is I tend to mount the piston on the connecting rod and then I work the cylinder over it. And the purists right now are going, oh, Lordy Jesus, take me now. And it's not the right way to do it, but it's the way I do it, and I've always had success and I've never had a leak. That said, this engine will probably blow oil like a $5 lot lizard. So it's getting late. I'm going to call it a night. Just got a call from one of my guys that one of our robots decided to see how fast it could drive itself into the wall. So I kind of have to wrap my head around dealing with that shit tomorrow. All right. Be good. Be kind to yourself. I love you. See you later.